4 normally are collected by National Bureau of Statistics. In this dataset, there is a lot of subsection which we need to be sorted out. Okay, first let's look on NPS questionnaire. In NPS questionnaire, there is almost 3 subsection. First one is the household section. The second was agriculture section, and the last livestock and fishery. In our case, we're going to look on household section. I mean household and individual questionnaire. In household and individual questionnaire, there is a lot of information here. There is section A. There is section A. Up to section V. So education are found in section C. Okay, there is some problem here, but that is the case. So we are going to sort out each section, and we're supposed to merge those files. Okay, these are sorted one. Our variable of interest, which are age of that household, education, I mean age of that woman, education, marital status, income, and location. All of these variables are found in section A, section B, section C, section N, section S, and section V. These are two different, I mean these are more than one different data set. So we need to merge all of these to have one data set which we are going to use it in our analysis. We have our starter here. It is starter version 14.1. So we need to merge all of these files. Then open. We're starting with section A. We open section A. In section A, there is a lot of variables, as you can see, but out of all of these variables, you're supposed to find one variable which is, which it appear in all section. I mean from section A up to section V in our household and individual questionnaire. This variable are Y4. This is a unique variable which is household ID. So in each subsection there is this, in each all of these subset of data section A to section V, they have household ID which is this, which resemble in each section. Okay, so we want to merge. We want to merge these 6 sections. This is a section. That was the first section. You're supposed to open section A, then to merge with section B as follows. If you want to merge, you come to interface, data interface, combine data set, then merge two data set. You click. As you can see, we have more than one variable. Then we have to choose here many to many in the key variables. Okay, that's fine. And key variable, you have to find the variable which match, which the variable which is common to all subdata set. For our case, Y4 HHID, which is household ID, is common to all data set. As you can see here in our in that section A data set, you can find there is this variable called Y4 hash HHID. Then you have to select it. Then you're supposed to browse the next data set, which is section B, so as to merge. So we choose section B, then we submit. Okay, our result shows that almost 16,285 variables are merged or are merged. And you can find before we have only HHA. Now after merge we have HHB. This is the section B, and new variable called merge obtained after merging section A and section B. So we need to drop this variable because we still need to merge with section C. So this variable is just shown as the whole process of merging the file. So we have to drop merge. Yeah, okay, yeah. No, okay, it's merge file is already dropped. Yeah. Okay, we need to merge again with section C, as we are using the same process as merging section A and B. Okay, merge data set, the ID is the same, hence we need to change or to add section C. Then this result, and we have again section C with new variable called merge. We have to drop it, merge. We pass the same process. We need to add another section, combine assets, merge. We need to change section N. We merge, we drop, merge the file. We need to add another data set, which is section S. Okay, we need to drop again. The last, we need to merge section V again. We have to drop the new variable called merge. Okay, now we have data set, merge the data set with section A and section B, section C, section N, section S, and section C. All of these fixed section is where we're gonna find the data set, the value of our variable of interest: age, education, marital status, income level, and location. Okay, I have prepared to you some syntax. Okay, before you need to save this data set, combined data set. You come to the file, then save as. You can rename any. For example, you can say human data set. The starter data sets are normally in a DTA format. Then you save it. So you can find that our file are found in this link. Okay, then we have some commands which we need to learn. I've prepared to use some commands. As you can see, these are some commands in each variable. This is our equation. This is our equation. There is head. You want to head is dependent variable which depend on age, education, location, marital status, and income level. Based on our start, our dependent variable has will be proxed by BMI. BMI is body mass index of that woman. In our data set, BMI are found in section V in household questionnaire. Section V in our household questionnaire. In section V. Section V, astropone. This is the area where we going to get BMI. Age, We obtain age from section B, household member roster. Here is where we are going to get age of that household, I mean of that woman. Also, we are going to get location in section B. We are going to get even marital status in section B. The income of that woman, we are going to get it in section N. Section N, family, household, and non-farm enterprises is where we are going to get our income information. Yeah. By starting with our dependent variable, when this is our all variable in this is 60 subsection, subsection. Okay, we browse to see our variables. Okay, we have a lot of variables. We need to do some sorting to create some syntax which will sort our variable of interest. For example, BMI are found in HHV 001. Okay, let me look. Let's see. Can tab HHV 01. Oh, you can find HHV 01 variable of only woman, which range to 15 to 99 aged. And so there is almost 3,000. 3,881 women who range in who are fall in this reproductive age. So everything which will do should consider that age. So education should be education of household range 15 to 99, location, even their marital status and income level. Okay, so we need to generate another BMI formula. Okay, let's find how to calculate a BMI. How to calculate a BMI. How to create a BMI. BMI is obtained by dividing variable V5 which is weight over square of height, which is variable 0.6, as you can find here. So we need to generate this variable. Just copy and paste here. Wow. Hence, this is our new variable, which is obtained by dividing V5 with V6. I mean dividing V5 with square of V6. Here we put 100 because height is supposed to be in meter, and our data set are in centimeter. So that's why we divide before with 100 to get meter. And then we have to browse. Wow. We have to browse data set. Okay, yeah, this variable, new variable which created, which you obtain after do some calculations. Okay, then after we need this BMI. These are body mass index for all data set. However, our start just look on reproductive age, so we have to put some conditioning to restrict or to sort only BMI of that reproductive age and not all data set. So we have to put another condition. Of which will restrict only for BMI of reproductive age. As you can see, there's a variable V01 is a variable for only woman in age 15 to 99, which is the reproductive age. So you have to put condition or to generate as a BMI which only look on that reproductive age. Hence we paste. Hence we create another variable which is BMI3, which is obtained from BMI1 given condition reproductive age. I mean from this variable, then we put enter. So we generate variable. However, almost 13,000 some variable are missing. Those variable which means they are individual who are not in reproductive age between 15 to 99. Okay, this is our new variable can look it by blues over. This is our new variable which we are looking for. Okay, the next step okay, you can just put summarize to see. Okay, this is now, let's put the sum. Oh, you can find that as the variable is BMY3, which is our main dependent variable. We found there are almost 3,206 observation, which represented the reproductive woman, BMI of reproductive woman in that age range. Okay, then after we need to create another variable, or to sort another variable for age, only age of those reproductive women. We have this syntax. Age of all households are found in section B, but we have to put some condition in order to sort only age of these reproductive women. So we have to generate, copy and paste, then we have to create a new variable called age, which is found in section B, but with the condition that age should be greater than 15 and less or equal to, should be greater or equal to 15 and should be less or equal to 99. Oh, then we learn, we found new variable called age with this missing variable. Then we look on that variable by close it. Wow. Okay. These are reproductive age, only reproductive age. These are reproductive age. Okay. Reproductive age. This variable is reproductive age regardless the sex. So as you can see, if you summarize, you found almost 70 something thousand of age between 15 to 99. However, reproductive women are only 3,000 something. So this is big. This observation is bigger than observation on our dependent variable. So it means there is even a man in this observation. So we needed to sort it again to remain with only reproductive woman. Hence we have to generate another variable which should be named different from the first variable. Let's put caps, then age, is equal to our first variable, which is age, if age is equal to, okay, let's just copy here. If HH4 is equal to 1, 1 means male, I mean woman, female. It's equal to age if this, then this variable are missing. So when we summarize our new variable, we obtain something like this. Okay, this observation are different from this observation. However, as some variables are omitted due to some compilation. Okay, that's our second variable, age. We are looking for third variable. Our third variable is education. Education is found in section C in our data set. As you can find, section C is here. Section C. Yeah, okay, find the section C. Yeah, it's about the education status, I mean education level of household. And so I have to generate a variable, a new variable, which will be of that variable will be of that reproductive woman. So the new variable we called, okay, let's put woman education. H7, the highest level of education of a member of household is 07, but they supposed to be in age of 15 to 99, but this it complies both male and female. So after this we need to sort only for men, for the female. This is the new variable generated. Again, we need to sort for only female. So we have to create another syntax. Syntax. The first syntax was women education, so I create another variable from that woman education, then it enter. Wow, that is the second, I mean the second independent variable. Okay. We need to create, I mean to do with, or to carry out with another variable. Our next variable is location, but it's supposed to be location of household in age 15 to 99, but it is supposed to be woman, age and woman for our reproductive age. So we have to generate this variable. Now this is location, but this is for both male and female, but we have to sort only for reproductive woman, so we have to sort only for female. Out of this, it's syntax this. Oh, wow. Yeah, oh, wow. Then we got our new variable, which named as LOC. The second variable is marital. The marital status of a household are found in section B. So we have to sort marital status for only male, for only female, female, for only female, given age, reproductive age. This is marital status for between 15 to 99, both household. Hence we need to sort for only female. Hence we have to generate another variable. Let me copy this. Then after we have to generate another variable called, let's put another ML to differentiate, which equal to call which is only for reproductive woman. Then we copy and we paste. Wow. This one is our variable of interest, marital status. Okay, let's see on our last variable of income. So we have to generate new variable. The income is found in section N, and it's supposed to be male. I mean, it's supposed to be female, age 15 to 99. Okay, then we copy and we paste. Yeah, we obtain this variable. After we close, no, let's close specific variable, which is household income. Wow, we got this. Okay. Okay, but when we see all variable, we see. Okay, nice. But you can find that these variable are very big in terms of numerical value to compare with other variable. So it's recommended to create another variable which will have the same, I mean the same impact on our regression. Yes, it's recommended we have to put loan on that variable to create another variable which will have the same impact but with very small numeric value. Wow. Okay, that was our last variable. Yes, we create. After apply log, we found little bit a small variable which is almost resemble with other variable. But in our data set, we can find we have a lot of missing variable, starting from BM3, age, education, location, I mean marital status, and income. So we need to drop all of these missing variables. Okay, drop command. Called drop. We have to look to base on our dependent variable. Drop here if is equal to missing variable. Wow, what's the problem? That command. Okay, let's try it again. You have to drop if what is the problem? To drop variable if drop variable. Okay, let me just Google syntax on starter command. Starter command drop missing variable. Wow, what a problem. There is poor internet connection. Okay, but that's not the case. Let's try to replace our variable. We're starting with the word leg means regression analysis. We put the first variable, which is BM3, which is in our start. BM3 is the health status of one individual. We proxy it by body mass index. With second variable is age. The third variable is education, marital status, location, and income. Wow, this is our final regression result. As you can find, BMI3 is our health. Dependent variables as coefficients. These coefficients are like this B1 up to B7. These are coefficients which we are looking for. In our start, almost all coefficients are positive. It means that all of these variables affect health status of an individual in a positive way. So age appear to be significant, location appear to be significant, and the income level appear to be significant.